Welcome to Two Bees in a Podcast, brought to you by the Honeybee Research and Extension Laboratory at the University of Florida's Institute of Food and Agricultural Sciences. It is our goal to advance the understanding of honeybees and beekeeping, grow the beekeeping community, and improve the health of honeybees everywhere. In this podcast, you'll hear research updates, beekeeping management practices discussed, and advice on beekeeping from our resident experts, beekeepers, scientists, and other program guests. Join us for today's program, and thank you for listening to Two Bees in a Podcast. In this episode of Two Bees in a Podcast, we'll be talking with Dr. Meghan Milbrath from Michigan State University, who is an expert on European foulbrood. So over the course of two segments, we'll be talking about European foulbrood and its treatment. Our third segment will be with Dr. Bill Kern from the University of Florida. He is joining us to talk about Africanized honey bees. And of course, what Two Bees in a Podcast is complete without the question and answer session. So thank you so much for joining us on Two Bees in a Podcast. So Amy, this is really kind of an important segment because we're going to be discussing European foulbrood, bacterial diseases in general, maybe some hot topics on issues related to bacterial diseases and honeybees. And joining us to discuss this is Dr. Meghan Milbrath, who is an academic specialist at Michigan State University and the Michigan State University Department of Entomology. She also runs a side beekeeping business as well, so she knows bees in and out. Thank you for joining us, Meghan.
Thank you for having me.
So Meghan, we had you on a few weeks ago, and you're actually being interviewed because when we put out a poll to beekeepers asking beekeepers who they wanted us to interview, did you know that your name came up multiple times, if I'm not mistaken, right, Amy?
Multiple times, yep.
So you're one of our earliest interviewees because people wanted to hear you. What do you think about that?
Thanks, guys. That makes me feel good.
Absolutely. So with that background, we've brought you back kind of for these two segments to discuss things that are near and dear to you. The first of those being European foulbrood and bacterial diseases. So what I want to ask you is, can you give us just a short overview of your history with these? Because we want to talk to you more about what's happening now, what you know now, and the hot topics related to this and what beekeepers need to know.
Sure. So my background is in studying disease transmission and environmental risks that cause disease. So that's kind of the perspective that I view a lot of situations. And in 2015 to 2017, I was working on a completely separate project it was a USGS project looking at the value of CRP land on honeybees. And we were evaluating a lot of colonies in the late summer, so July through September. And one of the things that was interesting is that we saw a lot of European foulbrood-like brood disease really late in the summer. And historically, if you talk to beekeepers, EFB's around, a lot of people don't take it that seriously or hadn't been because historically, you see it in the spring and then it always clears up. And so we were getting really good evidence that it wasn't clearing up. And so I started to talk to the commercial beekeepers that we work with about it. And they said in the past years, it's gotten worse. It looks and smells different, and it's absolutely not clearing up. And so we could kind of anecdotally confirm that it wasn't clearing up. And everyone was talking about, and there's this really strong association with blueberries. Like if you want to give your bees European foulbrood, it's always the ones that are coming in off of blueberry pollination. And the more I started to talk to people, that's universal. There's people working on this problem in Maine and Quebec and British Columbia and Oregon and New Jersey and all these places where they have blueberries. There's a really strong association with at least that time of year and colonies that are on blueberry pollination. And so again, we had beekeepers saying that it was a problem, but it's hard to write a grant saying it is a problem because beekeepers tell me it is a problem.
Sure.
And so we went out the first 2 years, we got what's called a green grant, which is internal to MSU in response to industry needs. And that allowed us to identify how bad it was. And in 2018, we found that 23% of the colonies that were in blueberries, this was working with 3 different beekeepers, were having European foulbrood, which I'm like, well, that's horrible. If, almost a quarter of them have it. We repeated it again last year, and it was 56%.
Well, Meghan, can I ask a quick question here? So, because this is a big issue to us in Florida. So, were the signs of disease manifesting historically as what we would call European foulbrood? Or the reason I'm asking this is because, we have a lot of beekeepers who have the crud, right? This thing.
Yes.
And I want to ask, because I have some sneaky suspicions, but I want to hear it from you. Are the signs of disease similar with what the beekeeping community is calling the crud?
Yeah, and so I have, and this is one thing that I think we do need to get together and come to kind of a consensus on. It's really difficult to study because the crud, snotbrood, atypical EFB, all of that has been studied so differently too that it's hard to say what is what.
Agreed
so
completely.
One of the things that I can tell you is we do see, so we followed these colonies, we inspected them 6 times over the summer, and I have so many photos of European foulbrood. And what we started to do is classify them based on the actual signs. So we had twisted larvae. So we had little codes, and we counted how many twisted larvae, how many visible trachea, how many yellowing, how many white blobs, how many brown blobs capped. And so we kind of went through and tallied to give a sense of what the sequelae were in a particular colony. We had colonies that had what we would call typical European foulbrood. So you had the corkscrew or the twisted larva, you had some yellowing of brood food, you had the visible trachea. We definitely had some that had also the ones that people would refer to more as like the crud or snotbrood, where it just looks like they melted.
Yep.
And the cappings, they were also living until the point that they were capped.
Okay.
And when you get into those, the ones that are capped have a very different smell because there's definitely some interesting secondary bacteria.
Okay.
When we had those, we still sent samples in to Sam at the National Laboratory, and those were testing positive for European foulbrood. So but I will tell you the things that I think, but not. So one is they are definitely, there is European foulbrood in those colonies. That doesn't mean they don't also have something else.
Okay.
We just got a grant through Project APIS-M and the National Honey Board to look at the viruses that are present. Because, honeybees, like any animal, can have as many diseases at one time as they darn well please.
Sure.
And so it could be that there is a secondary infection. We're also working with the group at Tucson, at the bee lab down there, and we've done these ridiculous paired studies where we take a photo of every single sign of a disease. So we take 10 twisted larvae, and we take photos of, this is what we're calling twisted larvae. We send them down, and they're doing the full sequencing and looking for the microbiome to see if there's different bacteria present. The other thing that might be happening is there could be a different virulence factor.
Yep.
So if you're living all the way until, so if you have a more highly virulent disease, it's going to kill them right when they're a larva, or when a young larva, like third instar. If it's less virulent, so it's less damaging to the bee, it could just be that it's not as severe of a disease at the bee level. They can survive until the prepupal stage, they can become capped, and then they die. So the University of Saskatchewan, we're working with them to figure out, if what we see in the hive is different to those things. I
think your statements are important because we hear this reported a lot, and some samples of the crud that we've sent off before years and years ago came back, very EFB positive. The struggle that I'm having is the lines between EFB, between the crud, and even between, for me, parasitic mite syndrome are very blurred. And it's hard for me to confidently know what it is we have, and then secondarily make a recommendation to beekeepers what to do. So it's really good to know that you're actually investigating that interface between these atypical brood losses that are clearly related in some way. So tell us more about how you're addressing that.
Yeah, well, and in the cases that we are seeing the atypical EFB, there's always signs of the more classic one, or not always, but there generally is, especially when you evaluate them over time.
Okay, so they co-occur.
So some of those earlier ones, a lot of times you'll see the melty, like when the disease gets really bad is when it switches kind of all to melty.
Okay.
One of the hardest things about using only visual diagnostics for honeybee diseases is when a bee dies at a certain age, it tends to look kind of the same, depending on what it died from. So with parasitic mite syndrome, that real white melty, This is too bad that this is over radio and not visual, because I have some really gross photos.
Well, gosh, man.
We can add that to our website.
Oh, yeah, that's true. Show notes. Okay. I'll give you some really disgusting photos for your show notes.
Can't wait.
So when you're looking at something visual, like that white melty is really, it seems to be when like a fifth instar. So right before they get capped is going to die. That's kind of the way that they die. Almost not entirely regardless of how they die, but if you die at that age, you're going to kind of look like that. So with the viruses associated with parasitic mite syndrome, a lot of times you do see that white melty. The things that separate that for me is, one, a history or current situation of having high mites.
Yep.
Two, a lot of times you'll have bees that are dying on emergence. So adult bees with their heads with their tongues sticking out that are dying is heavy in parasitic mite syndrome, but not associated with the bacterial diseases.
Okay.
That's always viral or pesticide-y. And then 3 is the timing.
Okay.
At least for us in the northern states, we're so cyclical. We don't get the big buildup of mites until late summer, fall. And at that time, the EFB, those colonies have dwindled way down. So we kind of differentiate on those points. One thing that is interesting that we found this summer was that we did sample at the very end of the summer for deformed wing virus, and we found colonies that had deformed wing virus at high levels, even in the absence of having mites. So we knew that mites were managed very, very well from May. And when we sampled them in August, there had been no peak in mites. Mites had been controlled through that whole period. We were monitoring the whole time. And we had colonies in August that had high levels at that point.
So, Dr. Meghan Milbrath, that's very interesting. If you don't mind, we'd like you to stay on with us for a second segment where we actually discuss, a natural segue, which is what can beekeepers do? What have they historically done, specifically with related to antibiotics, since it's a bacterial issue you're discussing largely, and then how that antibiotic and new veterinary feed directive kind of interplay and limit beekeeper ability. So, if you don't mind, we'd like to get you to hang around to the second segment.
Absolutely.
Thank you. That was great insight on what you do at your lab there.
All right, welcome back from the break. We're still here with Dr. Milbrath. We just spoke about European foulbrood, and so we know that there are, European foulbrood, American foulbrood that beekeepers kind of deal with. And, historically speaking, beekeepers generally used antibiotics to acknowledge these. So, Dr. Milbrath, what is your stance on foulbrood in general and using the antibiotics?
Sure. So I think that antibiotics are an incredibly useful tool, and we're very lucky that we still have some that are effective against the control of these diseases. And I use the term control, and I'll come back to that. Whether or not they're appropriate really depends on the context, and a lot of it is not necessarily the risk of that particular colony, but the risk of that colony to the ones around it. So our focus with these bacterial diseases is a lot of times it's different than other animal care, and our focus is not necessarily on making sure that this particular colony gets back to perfect health immediately, but how do we make sure that this doesn't go into a full-blown epidemic. So in some cases, it might make sense to burn the colony. In other cases, antibiotics would be the most appropriate tool.
It's interesting to hear you say that. So incidentally, before I ask you this question, I agree with you. And we're going to talk in a moment about the veterinary feed directive and prescriptions, et cetera. But when the VFD was announced, and again, we'll talk about that shortly, but when it was announced, I polled a lot of bee scientists around the U.S. and said, what are your feelings about using antibiotics in bee colonies? And probably 3/4 of them said we shouldn't. But I agree, I have a big commercial contingency of beekeepers in Florida, and I feel that they need access to those antibiotics, and there are appropriate uses of these things to control these bacterial diseases. So you feel the same?
Well, one of the things that I work a lot directly with veterinarians, and when I first started working with them, they really perceived this whole regulation as being a way to just get antibiotics out of beekeeping. And what I've done is really look at where the judicious uses for it. And we are balancing, it is probably 20 years too late that we've, just had antibiotics available willy-nilly, because we don't have that many tools and we do have to be careful how we use them. But we are balancing that with bee health.
Sure. And
there's no other animal system where you'd be like, we'd be fine with having most of these animals die with a bacterial disease as long as we're not using antibiotics. Like, that's just not a thing that we do.
Sure.
With honeybees, we are putting them in situations where they're under a ton of stress for the sake of our food system. So there's no other animal that we drive to such levels of stress for something that's completely separate than the animal. So we put them under high levels of stress. Then we put them in situations where they have high levels of mixing. Then we transport them around the country. If you want to create an epidemic, that would literally be the way that you would do it, is you would take all the animals, put them under stress with high levels of these pathogens in the background. So one of the interesting things about both European foulbrood and American foulbrood is they have high levels of infection even when there's low level of disease. Meaning that, so disease being when you actually see the colony being sick and showing signs in brood, infection meaning the pathogens present in the colony. So when you've got an apiary that has a sign of European foulbrood, most likely there are bees carrying Melissococcus plutonis in the background. Even in cases where you don't see American foulbrood, there's tons of the spores kind of out there in the world. So when we're dealing with these contexts, and we can use other animals as a guideline. So when we look at, for example, in large groups of animals under stress, like you can look at feedlots for cattle.
Sure.
If you're going into a feedlot with cattle, if you look at the Merck recommendations or the standard recommendations that a veterinarian would use, there's a whole list of vaccines that you would provide to that animal before it goes into a feedlot, knowing that the potential for it to get sick and to transmit disease is really high. We don't have those tools for bees. It would be awesome if we had vaccines and all these other tools, but really our only tool right now to manage these epidemics is antibiotics. And so we have to be really careful when we've got these, large herds of animals under stress, that we are seeing really high rates of disease that's actually killing those animals. We don't want to take away that tool. Now, there's a lot of other cases where people have been using them in ways that, you've got the old beekeeper who's been doing it for 45 years and never seen the disease and is completely removed. That's probably an extra use.
Sure.
But there's definitely places where it works really, it's very important.
Well, let me ask you a slightly controversial question. You don't have to be held to it, but a lot of our beekeepers, when they, again, EFB and AFB, clear ideas on how to address those. There's a lot of information available. We'll probably even discuss it in future podcasts. But on the other hand, something like the crud, which is a little bit more amorphous. We're not sure exactly what it's caused by. A lot of our beekeepers try to rescue colonies with the crud by using antibiotics, just under the assumption that it's bacterial linked. Do you have a statement about that? I mean, I'm not going to say whether you endorse it or not. I'm just asking, do you have a statement about that approach?
Yes. So with EFB, and I do include the crud, we mostly call it atypical EFB because we have seen it come in there. And we've done 2 mini studies. A PhD student, Gabriella Quinlan, led them here on looking about the effectiveness of antibiotics compared to supplemental feeding and things like that. And antibiotics do work, and they work more quickly.
Okay.
And so there is still a role for them in those contexts. And the colonies that weren't getting it, that were allowed to recovered very, very slowly and did not make honey for that year. So in those contexts, I mean, you can, in my mind, honeybees are animals and they do deserve to be in good health. And there's a role for antibiotics when a colony is sick or when a colony is likely to become sick, that we want to make sure that they are in good health.
So Megan, you just said something I've just really heard no other scientists say publicly, this idea that honeybees are animals and they deserve to be in good health. That is something that's near and dear to me because a couple colleagues from Europe are putting a book together called The Welfare of Managed Bees. And the whole premise of the book is honeybees are animals and they deserve to be in good health. And I had to write a chapter in that book, and it brought to attention to me the ethics associated with keeping honeybees should be similar to those associated with keeping cattle or poultry, et cetera, where the animals deserve to be in good health while they are under our husbandry practices. So I love that idea, this idea that antibiotics play a role because honeybee colonies deserve to be in good health. So let me appreciate that statement for what it is. Thank you for making it, and then move on to the next part. So, despite all of this, despite the role that we think that antibiotics have, at least in certain contexts with European foulbrood, the crud, American foulbrood, and other things, beekeepers find it a little bit more difficult to get it than they did a few years ago. In 2017, the FDA put forth the veterinary feed directive. So beekeepers could no longer just purchase antibiotics. They now have to have either a vet feed directive or a prescription, depending on antibiotic use, to get those antibiotics before they can be administered. Could you give us a brief overview of the VFD and how beekeepers are having to get a hold of antibiotics now in order to address these bacterial diseases that you've been discussing?
Sure. So the veterinary feed directive was put in place in order to reduce the use of medically important antibiotics in food-producing animals. It was really targeted at poultry, cattle, swine. Honeybees, though, do fit the definition, and fish were also caught into that. And so by definition, they're considered minor species for this, but they did fit that. At the same time, the FDA released this 5-year plan, or a year later, for a 5-year plan for supporting antimicrobial stewardship in veterinary settings. So there's this really big push amongst the FDA and the food community and the veterinary community to really reduce the risk of having antibiotics in our food system, which is lovely. It's going to be a tough transition, though, just to kind of sort that out and how people have access. I just went to a meeting with the AIA, the Apiculture Inspectors,
Apiary Inspectors of America. That's right. Too many acronyms in our business.
It was the ABF, AIA, ABRC meeting, and
ABCD.
And we talked about it. And a lot of them are really on the front lines of dealing with a lot of these issues and talking to people from all around the country. Different states, it's working perfectly fine. In different states, they're really struggling. Mm-hmm. It really shouldn't be a hard thing, and it's not an enormous obstacle once veterinarians understand it. So the big issue for beekeepers is to understand that the veterinarian's license is at risk. So if they're saying that they're not comfortable doing that, that's reasonable because they don't want to get hauled into court.
Sure.
And they don't want to lose their license. And ultimately, these laws do get played out in the courts. Mm-hmm. And so if your veterinarian doesn't want to deal with that and they're not comfortable, that's fine.
Sure.
However, veterinarians are really used to dealing with these situations. One of the issues that I've seen is when people feel like they haven't been able to get antibiotics, it's usually because they're going to the wrong type of veterinarian. So your small animal, your cat and dog vet is really used to saying, does this dog need antibiotics? And in that case, yes or no, they meet your dog, you bring it in, that's very different. A large animal vet that is used to working at dairies knows that they don't need to go out there and inspect every single one. They're used to prescribing antibiotics for high risk scenarios where you're controlling disease as well amongst the herd. And so there's different scenarios, and they're also used to dealing with food producing animals and withdrawal times and things like that. So a lot of times it's finding maybe a large animal vet to work with who's completely used to prescribing those types of things.
So one of the things the beekeepers kind of struggle with this issue because they have to understand the issue and maybe feel like they have limited access to antibiotics. So there's that education. From the vet's perspective, Meghan, what I tend to see the issue is you just said, you see a dog, the question is, does this dog need an antibiotic? With European foulbrood, that's pretty easy. A colony has European foulbrood. Should I elect to try to rescue it with an antibiotic? On the other hand, they struggle with American foulbrood because when American foulbrood presents, it's fair for that colony to not exist, right? And so vets are going, why would I prescribe an antibiotic to, quote, rescue a colony with AFB when all it does is cause the physical manifestation of the disease to go away, but the spores are still present and the disease can come back. You don't actually cure, as it were, or treat a colony with antibiotics for American foulbrood. So they struggle with this idea of prophylactic use of antibiotics in context with honeybees, specifically with American foulbrood. Any comments on that?
Yeah, so I think you brought up actually kind of like 4 different topics in that I've been working with veterinarians.
Great.
So one of them is, I'll do the easy one first. So prophylactic use, I don't think is appropriate in the case, that term for bees.
Sure.
There's another term called metaphylactic use. And metaphylactic is more based on control when something has shown up in the herd.
Gotcha.
So if you've got a diseased animal, it makes sense to provide antibiotics to everybody who else is at risk, like if they're feeding out of the same feed trough. Whereas prophylactic means like we've never seen it and we don't really see a chance of it. Most of the commercial beekeepers, they're having, so for the example of European foulbrood, if they've got 5 years where every time they go into blueberries, they're going to get EFB, that's not true prophylactic use because we know Melissococcus plutonus is present in those hives. It just requires those risk factors to actually cause the disease. So I think there's a perception that when beekeepers are using antibiotics that it's not necessarily like necessary or not related to
this idea that it's the
event.
Wild West, right? The Wild West of antibiotics. I love what you just said. Clearly your human disease background's coming into play there. Metaphylactic. I like that idea. I've never heard it explained that way. And
then going with the treatment of, so the other thing that a veterinarian has to do is they don't necessarily have to understand everything about honeybee biology and splits and queen rearing. They have to understand, are these appropriate contexts that would be good for antibiotics? And so the example that I use is like a veterinarian is licensed to treat a bearded dragon. They don't have to know everything about bearded dragon nutrition. They have to be able to go up, look through their resources and say, is this an appropriate time to give this treatment to a bearded dragon?
Sure.
With honeybees, what we're trying to do is provide them with resources. So we have a guidance document on American foulbrood, and they can look at it and say, okay, nobody would recommend just giving a colony with American foulbrood antibiotics. Where antibiotics come into play with American foulbrood is, let's say you've got a beekeeper with 5 hives, one of them shows up with AFB. They can do a shooks, and they're in a state that doesn't require the apiary inspector to come in. So Michigan, for example, and I've gone through this situation, and they can come in, they can do a shook swarm and shake that colony onto new equipment, burn all of the old equipment, and provide everybody in that yard with antibiotics because you know that there are bees that still have the spores in their crops.
Sure.
And what you're trying to do is prevent reinfection of those other colonies until those spores have passed through the bees and we're back down to background levels.
Sure.
So that would be a context in which, you're mixing the burning. And even in the case where if you have a beekeeper and they burn a hive, that would still be appropriate to give antibiotics to the other bees in that yard,
Sure.
knowing that there's a lot of that infectious material present that could just pop up again. And then you monitor after that, and if you don't see it anymore, then we're good.
Yeah, I mean, I think that's super important. I mean, I think that's well said. Our beekeepers have struggled with a lot here in Florida. I know veterinarians have struggled. In fact, next week, I know when you say next week on a podcast, that's irrelevant, but next week I'm going to actually train veterinarians on this particular issue, and you've certainly given me some food for thought. Meghan, you've been a fantastic guest telling us about EFB, a little bit about the crud, telling us about the VFD and antibiotic treatments. I've personally learned a lot, so I thank you so much for joining us.
Yeah, absolutely. And can we just all agree that honeybees are just unique in their own world as far as how to treat them and how we manage them and, the recommendations that we give out.
So, Meghan, thank you.
Thank you so much for having me. I also would like to, I have lots of resources for veterinarians
Oh, please tell us
on our
about
website.
Yeah.
So it's pollinators.msu.edu. And if you go to the programs tab, there's something that says Bees Need Vets. And it's got examples of how to fill out a VFD, context when it's They're important to use. Different places, there's online classes through AVMA. I'm starting an online class through the Veterinary Information Network. Well, it'll be tomorrow for me right now. So whenever
Sure.
there's lots of online resources that veterinarians can use so that they're comfortable working with beekeepers.
Megan, if you could get us those links, we'll put them in our show notes and make sure that when this is
Absolutely.
published, the listeners have access to it. So listeners, that was Dr. Meghan Milbrath, an academic specialist at Michigan State University in the Michigan State University Department of Entomology. What a fantastic interviewee that was. I mean, Megan, you're great. Thank you so much.
Thank you. That was fun for me. Thanks, guys.
Thank you.
For additional resources, visit the podcast page on our website, ufhoneybee.com.
Amy, have you ever wondered about African honeybees?
All day, every day.
Why is that the case?
Because
you
they're
think
talking about African honeybees right now.
Okay.
So I just thought about it, and then I just figured I do think about it
You
all
know,
the time.
when I got hired, people were always emailing me and calling me about Africanized honeybees. And the principal reason is because when I got to Florida and started working at UF, that's the thing that was the big deal. But very shortly thereafter, people began being concerned about bee losses. And so all the phone calls and emails I received shifted from African bees to that. Do you get those calls?
They shifted on because they shifted over to me, Jamie.
Well, what do people ask when they're contacting you about it?
Well, they're just wondering if they're African honeybees. Actually, every time they see a wild or feral colony, they just tell me, "Oh my gosh, we have Africanized bees. We have Africanized bees." And I'm like, "Okay, just hold on a second."
Well, you know, depending on where in the U.S. or even in the state of Florida they could, in fact, be seeing African bees.
For
Well,
sure.
to get to the bottom of this conundrum, we are joined today by Dr. Bill Kern. Dr. Kern is Associate Professor of Entomology in the Entomology and Nematology Department here at the University of Florida. He works out of the Fort Lauderdale Research and Education Center. Dr. Kern, Bill, thanks for joining us on Two Bees in a Podcast.
Well, thank you.
So before I ask you the first question, I want to set the stage just a hair for our listeners. You know, Amy, there are 9 species of honeybees. You know that, right?
Mm-hmm. Yep.
The one that we keep, Bill, as you know, is Apis mellifera. That bee is distributed in Europe, the Middle East, and Africa. So in those 3 regions, Europe, the Middle East, and Africa, there are different races or subspecies of this bee.
Okay.
So the one that we call the African bee is one of those subspecies or races from Africa. So, Bill, from Africa, how did we get the Africanized honeybee?
Well, there was a researcher in Brazil who decided he needed to make a better honeybee for the tropics. And most of our honeybees are from Europe. They're European subspecies.
Sure.
So they're adapted for long winters where they will store lots of honey so they can overwinter.
Sure.
But they don't do well in the tropics. And so he went to the same latitude in Africa and collected native bees from that part of southern Africa.
Yep.
And brought them back to Brazil to hybridize.
So the one subspecies he brought, though, is Apis mellifera, that's genus and species, but scutellata, right? That's the bee that came over.
Right.
Scutellata what?
Yeah, no, Amy, this is how you remember it. When you meet the African bee, you want to scutellata tail pretty fast. Come on, that's good, guys. That's good. I use that joke every time I teach about African bees. Okay, well, that's how you remember it. So this Brazilian scientist brings Apis mellifera scutellata to Brazil. What year was that, and what happened after that?
It was approximately 1957.
Yep.
And there's a lot of folklore about what happened next. And depending on who you talk to, the story changes.
Yeah, of course.
In some cases, they say a grad student or a technician saw the queen excluders on the front of the cages or the front of the hives and decided, well, that didn't look right, and he took all of the queen excluders off.
It's always the grad student or technician's fault.
Yeah, don't blame anyone else but the students.
Absolutely.
However, talking to other people working in South America, they said, no, he was giving queens away for other people to try. So, however it happened, they became established in South America, and then they were so successful that in a fairly short period of time, they literally took over most of South America. By 1967, they were all the way up into Colombia.
So what do you mean by take over? How did they take over this area?
They just they just multiplied and spread. Because the honeybees that they were using in Brazil were not adapted for the wet tropical environment, it was constantly a struggle to keep them going. But the Africanized honeybee, this hybrid, actually thrived and multiplied. And one of the characteristics of it is it likes to produce lots of swarms. And so very quickly it filled up the available niche in Brazil, Uruguay, Paraguay, all the way through the eastern part of South America. And eventually it had to go up around the northern part and start working its way back down on the other side of the Andes. And then approximately 1967, it started working its way up through the Central American Isthmus. And by 1980, it was as far north as approximately Nicaragua. By 1990, it had made it through Mexico and had just reached the southern tip of Texas.
Now let's think about that for a second, because Amy, you just asked about the spread. How did it spread? How did it take over? And Bill's talking about this spread. One of the things that people don't appreciate about African bees, and in my opinion, when we think about African bees, we think about killer bees and all the stings and all that stuff. But one of the things that I don't think appreciated enough, if they were introduced in 1957 in one spot in Brazil, and in 1990 they had made it to the United States, they had conquered that region largely on their own. It wasn't really beekeepers who were moving these bees.
So they weren't managed.
Exactly. And so a lot of scientists consider African honeybees one of the most successful biologically invasive species of all time. And once it got introduced, the climate, the conditions were right, and it spread largely on its own through this reproductive swarming, Bill, that you were talking about. So you keep saying, I keep using African, or you keep using Africanized. What's the difference between an African bee and an Africanized honeybee? I think that's key as we talk about this moving forward.
Okay. When you talk about an African bee, I'm basically thinking about that subspecies located in the southern tip of Africa.
That's right, scutellata, yep.
Which is Apis mellifera scutellata. But there's also lots of other really cool bees located in other parts of Africa. So I don't particularly like the African bee for scutellata.
Sure.
Africanized is basically a hybrid that is of African descent.
Sure.
So it has Apis mellifera scutellata in its ancestral history.
Sure, and I think what's key, you listeners, to understand this is there are already European strains or subspecies of mellifera in South America. So when this African bee, this scutellata, arrived in Brazil, it began to hybridize. And how could it hybridize? It hybridized because it's the same species of bee. They're both Apis mellifera. So once it made it to South America, Central America, and of course North America, it ceased to be the African honeybee, and it became the Africanized honeybee.
Correct.
So I guess one of my questions is, and I receive this question quite a bit, is you were talking about how they swarm more often. They probably have different characteristics, right, as far as the European honeybee that we keep. I hear that their venom is more dangerous, Bill. Is that true?
No, that's not true at all. I mean, it's the same species. It's Apis mellifera. So it is a Western honeybee. They all have essentially the same venom components. If anything, Africanized bees, because they tend to be slightly smaller, would probably deliver less venom.
Per sting, than a
per sting.
European-derived bee. So, these bees move up through Central America, they move up into North America, and then we get all of these terrible movies in the 70s and 80s about the killer bees or the bees from Mars or all these other dumb things.
The bees that swarm an entire car and make it blow up.
Yeah, so why? I didn't see,
I didn't see that
movie.
one.
I'll make it, don't worry. Coming out to a theater near you.
So how did they get the moniker killer? What's killer about them? Are they rad?
No, they're just very defensive at the colony.
Okay.
And we have had fatalities. But we've had fatalities with the Western honeybee if you have somebody who's allergic, it only takes one sting to be fatal.
Yeah.
And no matter what most mothers tell you, their kids probably aren't allergic to bee stings.
Yeah.
They swell up, which is called the large local reaction. And
I mean, I think one of the things that you said, Bill, was absolutely key there, this idea that they're defensive. So you're not, they got the killer name because you're right, there have been human fatalities. Unfortunately, obviously, that's terrible. There have been animal fatalities, et cetera. There have been a lot of people attacked by these bees. And the principal reason for this, and the way that I teach it, is these bees are simply more defensive than the bees that we typically keep. Mm-hmm. That simply means that when you agitate their hive, they're likely to respond with more bees and follow you a greater distance than a European colony would. So you're just simply getting more attention and more bees attack you. I think I heard, Bill, that the average human being can take 5 to 10 stings per pound of body weight before you just die of venom toxicity. So the average 100-pound individual can take somewhere between 500 to 1,000 stings before they die simply because they have too much venom. So if people who are not allergic to bees are getting killed by these bees, that means they're getting 500, 1,000 plus stings. So with that in mind, what would be a recommendation to people who find themselves attacked really by honeybees in this regard, but yellow jackets or hornets or anything that's stinging them in great numbers?
Run away.
But don't jump into a pool, right? That's what I hear.
Don't jump into a pool. Don't jump into a pond unless you have gills, because you're going to have to stay under for quite a while. So normally we just say, run away as quickly as you can, get into a structure or a vehicle if possible, close the door, and if you have a few bees come into the car with you, don't jump out of the car. Those handful of bees can only sting you, one time each.
Mm-hmm. So should we be scared of them? Should I be scared and just stay inside for the rest of my life and never go out?
Yes, but not for bee reasons.
For other reasons. The pollen right now is pretty bad. So
yeah, I wouldn't consider Africanized bees to be a reason to hide in your house.
Yeah.
It's just like if you're living anywhere in North America, they probably aren't much more threatening than, say, a colony of yellow jackets.
Yeah, that's how I usually tell people as well. Mm-hmm. I think one of the things, when people are getting stung in a mass stinging event, now we're not talking about you grabbed a flower and there was a bee on it, or you're walking barefoot through the yard and step on a bee, but when you're being stung multiple times, it is usually because you are too close to the nest. So the bees are trying to communicate a very simple truth. You're too close to our nest. We don't want you here. Mm-hmm. Go away, right? Mm-hmm. We kind of laughed when you said run earlier, but that really is the response. Sure. When you are being stung multiple times in kind of a mass stinging event, the best thing you can do is get away quickly to remove yourself from what is likely a nest somewhere right around you. That's why jumping in a pool is not good. Jumping in the bushes aren't good. You need to get away. I was going to say, is there like a specific way you need to run? Because when you run away from gators, you're supposed to run into zigzag, right? Because they can't, that's what I hear, because they can't turn. Jamie's looking at me all like, you're insane. The last gator that chased me, I just ran straight. Well, they say run into zigzag, and that way the gators can't get to you as fast, because then they have to turn. Are we talking about football now? No, it's easy to run away from a Florida gator. Is there a certain way that you need to run? You can just run straight if you're trying to get away from the Florida gator.
You're trying to get away as fast as possible.
That's fair. So that's fine.
Straight is good. I mean, if you're on a curvy trail, follow the trail so you don't trip. But
you don't stop, drop, and roll?
No.
Okay, cool.
Do not. Yes. That's for fires.
Yeah, good point.
All right. And trust me, if you roll on bees, they will sting you.
Yeah.
Even if they're just, hanging on you, they will sting you if you squash them. So you want to run away, put as much distance as you can between you and the colony. It is
interesting, though, that you raised that point. Amy, is there a correct way? When you read like the literature on how to respond, how to get away from African bees, they will often have a kind of cartoon drawing where the person being attacked will pull their shirt over their head. The idea is that you're trying to cover your airways, your face while you run, but I don't know what running through a forest with a shirt pulled over your head will accomplish. You're far more likely to be knocked out by a tree than stung by
That's
a
right,
bee.
unless you're wearing a really thin shirt.
Yes. I guess. But so I think the key is to get away as quickly as possible. Now, we really talked about this from a public response. The other thing that I would say to the general public, if you have bees nesting in your property or a tree or in a wall of a house or in a chimney, you really need to contact either a beekeeper who can provide removal services for you or a pest control operator who will eradicate. That's true here in Florida. that's no doubt true in the Southwest, where there's a much greater population of African honeybees. But, African honeybees are not just an issue. Africanized honeybees are not just an issue for the general public. They're an issue also for beekeepers. So, if anyone is trained to handle honeybees that are stinging, right, that's the beekeeper. But there are some unique situations that beekeepers find themselves in, and they have to address African bees in those situations. So what are some things beekeepers can do to minimize the impact of African bees on their beekeeping operations?
Well, we've put together a list or a collection of best management practices so that if people collect either African swarms or do what we call a cutout, a removal of a full colony from a structure, all right, there are certain things that the beekeeper should do if he wants to bring those bees back into domestication. First thing is requeen.
Sure.
Remove the original queen and replace her with a clipped queen of known genetic background.
When in doubt, get her out.
Mm-hmm.
Yep.
I made that up on the fly.
You did. I was very
awesome
impressed.
Sauce. Listeners, 2 Bees in a Podcast, that will be our next T-shirt slogan. Which simply means requeen.
Bill
when in
doesn't
doubt,
know how
get
to
her out.
respond to you right now.
All right, Bill, you keep being professional. All right, so we requeen.
All right, so
got it.
And within a short period of time, the colony will revert to the new queen's genetics. Mm-hmm. And so, we can convert an Africanized colony back to a European-derived colony.
Sure.
And there's certain benefits to that because European honeybees, because they're adapted for long winters, are better at honey producing.
Yep.
If you're primarily concerned about pollination services, Africanized bees are just as good as any other race or variety of honeybees.
It is important to point out, though, that in some states, like Florida as an example, it's illegal to keep African bees. And so, really the queen is the key. If you have a defensive colony and you suspect it could be, Africanized honeybees, it's best to just requeen it, right? That's the real key. And for that matter, that's just my general recommendation with defensive colonies, right? I don't feel like we should be stung a lot when we're working our bees. And if we are, just requeen the colony and hopefully you'll get one that's more gentle.
Last question I have, I guess, for you guys is how long does that typically take? As far as, once you requeen, how long should you wait? If I go back in a week or two after and I open it up and it's still just as defensive?
I would say you'd probably have to wait at least a month.
Yeah, I'd say the same thing.
Because it's going to take 21 days for the new bees to be replaced.
One of the things I want to point out to you listeners, we're talking about requeening defensive colonies. Now, you've got to remember that it's very common in beekeeping for our colonies to just lose their queens. The queens die, they're usurped, they're replaced. She swarms, the bees make a new one. Even new queens that you produce in your colonies in areas where African bees are present are a risk to you because your queens, your virgin queens, will go out and mate with drones from colonies available in the area. So even if you're doing the best you can to keep, European-derived stock in your apiaries, your colonies can become Africanized over time if you're not watching closely and addressing requeening or natural requeening in your colony. So I think that's an important point to make as well. Dr. Bill Kern, you have been a fantastic guest and certainly are an expert on African bees. Thank you for joining us for 2 Bees in a Podcast.
Thank you.
Guys, that's Dr. Bill Kern, an associate professor in entomology from the Entomology and Hematology Department at the Fort Lauderdale Research and Education Center, the University of Florida.
We've also referred to him as Ant-Man in one of our previous question and answer sessions. So we'll hear more about that in future episodes.
Well, Bill knows everything. Everything I ask
It's like a Marvel character.
Yeah, he's good. So I really appreciate your expertise, Bill. Thanks for joining us.
You're welcome.
It's everybody's favorite game show, Stump the Chump.
We're here with myself, Amy, Jamie, and Umberto answering your questions.
Umberto,
today.
it's really too bad your name doesn't rhyme with ours. Because then we could
Amy,
be...
Jamie, Schmamie.
Yeah, you are now Schmamie.
People call me Dr. B sometimes.
Okay, that still doesn't rhyme, Umberto. I'm not sure how that helps. Nevertheless, we did get a good question, Umberto. I think you're the guy to answer this question. A listener said, I treated my colonies for Varroa. And shortly thereafter, they didn't put a time frame on, but let's just say weeks, maybe 6 weeks or 2 months, close enough to the treatment. I started seeing Varroa again, and my bees had deformed wing virus. So, what's the deal?
Well, first thing that come to my mind is that the treatment didn't work correctly. Second thing that come to my mind is there is no any treatment there is 100% efficacy. So there is always leftovers of mites, and of course, if there is the virus there to be transmitted, this virus is going to continue in the hive, and in about 6 weeks, things go back to normal. So I would say that in cases like that, is a good indication for the beekeeper to retreat it.
Yeah, I agree. I mean, if you're seeing Varroa again after treatment, it's possible the treatment didn't work, or it gave you its best shot, and Varroa population just rebounded too quickly. So retreat if necessary. Sample colonies, retreat. That's a good answer, Schmamie.
Oh, Schmamie, that's me now.
All right. All right, Amy, your turn. I see you laughing, but see if you can spit out a question for me.
So I'm a scuba diver, and there's this thing that people talk about where they don't allow bananas on a boat. That's actually a thing. Recently, I've been hearing...
What if it's a banana boat? Because those things are real,
I mean, the next time you go to the beach, you should carry a banana on a banana boat.
Okay, so why can't you take bananas on a boat where you're scuba diving? I have got to hear this.
I mean, it's bad luck. It's considered bad luck.
It's bad mojo.
So that transitions me into that question that I was going to ask you was, people are talking about bananas in an apiary. They say that you're more likely to get stung. Bees don't like bananas. What's going on with that? What is that? What's happening?
I can tell you, Amy, it has nothing at all to do with luck, because in the bee world, we're not superstitious, you crazy scuba divers. All right, so the reason that question comes up is because the chemical responsible for making bananas smell like bananas is isoamyl acetate. And as all you astute beekeeper listeners know, that is also one of the ingredients of honeybee alarm pheromone. So when honeybees sting you, they deposit a pheromone on you that tells other bees, sting here. And if in that deposited pheromone there's isoamyl acetate, then it makes sense in our minds that if we eat bananas or have handled bananas, perhaps we have that on us, and when we work bees, we might be in for trouble. So I have never seen a research project on this topic, but I have eaten plenty of bananas before going and working bees and have yet to experience a problem. So I will not say that it doesn't cause a problem. I will just say that it has never caused a problem for me.
Interesting.
I've never had bad mojo eating bananas before working bees.
Eat a banana.
Neither do I. So, Amy, we receive some requests sometimes, and there is a question from a viewer. And the question is why we recommend, why people have to charge for bee removal when they have bees in their homes and things like that.
Yeah, so that's actually a call that we get 95% of the time here at the office, and even when I was an extension agent, and people would always say, we have feral bees on our property and we're wanting someone to come get them. We'll give them away for free. And I usually let them know, hey, that's not really how that works. So we do have, here in Florida, we have a Department of Agriculture list of bee removal companies or individuals, and they can go out and do bee removals, and I usually let them know it's not going to be free. It actually does cost a fair amount of money, and that's generally speaking because a lot of the people doing bee removals have either general liability service or general liability in general, and it really is not free. I mean, think about the time that it takes to drive out to a property, picking up bees, and then the materials that needs to happen as far as some people use vacuums, they'll vacuum up bees, the materials, and then bringing it back onto their property and having to maintain these bees. Sometimes these bees aren't exactly the healthiest. Sometimes there are just a lot of expenditures that come with it. And really, it's a time commitment as well. So there are lots of factors that go into bee removal. It's not just, grabbing this free gift that you're having and taking it back to your property.
Yeah, I think that's key, right? The premise behind the idea is, aren't you getting free bees? Then why are you charging me to remove it? But there's work involved in bee removal.
A lot
There's
of work.
training involved in the background of these individuals. There's liability insurance. And so they should be paid. It is fair to be paid to remove bees.
Can you guys imagine having honeybees, within the walls of your house, and then someone coming in and opening a wall in your house and just taking bees and going away and not cleaning it up?
I can imagine that almost as much as I can imagine not having a banana on my boat because I'm about to go scuba diving. Hey, you guys have been listening to Two Bees in a Podcast. Thank you for those questions. You can always submit more questions through our Facebook, Twitter, or Instagram accounts at UF Honeybee Lab.
Thanks, guys.
Thank you.
We'd like to give an extra special thank you to the following: to our editors, Shelby Howell and Bailey Carroll, and to our audio engineer, James Weaver. Without their hard work, Two Bees in a Podcast would not be possible. So thank you.
For more information and additional resources for today's episode, don't forget to visit the UF-IFAS Honeybee Research and Extension Laboratory's website, ufhoneybee.com. Do you have questions you want answered on air? If so, email them to honeybee@ifas.ufl.edu or message us on Twitter, Instagram, or Facebook at UF Honeybee Lab. While there, don't forget to follow us. Thank you for listening to Two Bees in a Podcast.